Hey there guys, and welcome back. So, as discussed earlier in the project updates video, we will be doing a decoiler slash coiler. I called it unwinder earlier, one of those things. Potato. So, as the thumbnail should indicate, this is going to be a rather straightforward build because it doesn't need to be any more straightforward than it is. It doesn't need to be any more complicated, I should say. Sorry, I'm adjusting my volume here because for some reason it ended up a bit loud in my ears. So, regardless, very simple concept. Basically, we're going to have, let's turn it this way. Obviously, we're going to have a spool that wire is either going to go onto or come off of. We're going to have an encoder with an idler wheel. One of those things. It could be either direction. It could be down here or up here. Doesn't necessarily matter. And then somewhere, and it depends what you're trying to do, you're going to have a motor. And in theory, you don't even need a motor. In theory, you could have a crank wheel. You could have just your hands pulling. Could be anything, really, when it comes down to. You just need a source of motion. And if the motion is on the coil, then in theory, it should be going this way, and you should be coiling. So I take a motor, put the motor right here. I guess I'll draw a little sprocket on it. Yeah, that's a sprocket. Yep, definitely a sprocket. So if the motor's right here driving the coil, in theory, you're coiling it up. Otherwise, you can move the motor out here. There's my sprocket, fancy sprocket, and it will pull the out. Now, pulling it out is a little bit difficult and a little bit hard to define. So this sprocket could either be, in theory, before or after these idlers right here. This right here, it could technically also be against the encoder. So this, instead of being an idler, could be what the motor is attached to. There's a lot of different variables here. The easiest way is, frankly, to just have another coil over here and coil off onto this coil, just because you can fix the loose end onto the coil and then you don't have to worry about it going. You don't have to worry about friction. And a reason to do it this way, to have a motor separate from the encoder as opposed to trying to predict how much wire is coming off, is that if there's any slippage at all, if you stop pulling wire or you stop coiling wire for whatever reason, the encoder is going to pick that up. So you know exactly how much wire is passing between this point and wire, ribbon, whatever it is. I'm saying wire generically as, what is being fed through this thing, but it could be ribbon, it could be whatever. So long as you rely on the encoder to read how much is going, then how you're pulling it doesn't really matter. Again, it can be anything, and it doesn't necessarily matter where this motor is, so long as the motor can get some grip on the material, if you're using a motor, and move the material. So that is that. Again, very simple design, using up most of the page just to draw a couple circles. Yeah, I can't really think of anything else to say right here, so we'll talk about this random stuff that I have on my desk. So I have a bunch of 3D printing filament, spools. So would be kind of nice to be able to use these to coil things up. So I need to be able to make something that is at least, I believe this is about 8 inches. So about 8 inches, preferably a little bit bigger, just in case. 3D printing bed is about 8 inches square, so not really ideal to print that close to this design. Now, technically speaking, any stand that we make only has to come up to the midway point plus a little bit. So technically speaking, the stand only has to be 5 or 6 inches tall, about yay tall, just tall enough to be off the ground. So we can do that. Alternative is back to alternative materials. So 2020 extrusion. I have 2020 extrusion for a reason, to build with. Also, as I've stated before, conduit is cheap if you don't feel like spending the money on 2020 extrusion, which, as I've explained, frankly, at a per foot cost, 2020 extrusion is not prohibitively expensive, having done the math myself. However, I can understand if you're trying to go as cheap as possible. Again, just EMT conduit, can be used as a building material. And otherwise, basically anything, I mean, heck, if you want to use just linear rods, this is a 5mm, depending on your application, may or may not want to use this one, may want to use an 8mm. But fact of the matter is that the stand for the spool doesn't necessarily matter so long as the stand for the spool is big enough. Also, if we're decoiling one of those things using one of these 3D printing spools, you can find online a whole bunch of spool stands, and there is a whole entire class of them that only rides on the bottom. You just put a couple of bearings down here, and that just basically allows this to free spin. It's basically in a cradle. So if you imagine my hands right here being the thing I'm trying to explain here, the base that has some bearings where my index fingers are. Okay, it has some bearings like on my index finger and on my ring finger, okay? And that basically allows this to free spin in a little cradle. So that is also an alternative, but that would only be in theory for decoiling. You could try to make it work with coiling, but you still need to get the motor driving this thing, which may be an issue, may not be an issue. I mean, it's one of those things. It depends how much torque you really need. So for example, if it's pretty difficult pulling whatever you're pulling here, and you try to mount the motor right here, or you attach the pulley to a motor and try to do it, you may have an issue where this wants to torque off the side or potentially back as well. Or, forwards, pull the whole entire bed forwards, the little cradle I'm telling you about, it could also pull the cradle forward. So there are things to consider, but one of those deals, we will leave that up to you. I'm actually thinking at this point, having said all that maybe because this design today is going to be so easy, maybe I make up 2 designs, one with the 2020 extrusion, one with maybe 3 designs. One 2020 extrusion, one with an A-frame, spool holder. Although, frankly, I might not do this one only because there actually are plenty of designs online for spool holders like this. So actually, I may skip this one. But conduit and 2020, though, are 2 other options we have. So only thing I might say about this A-frame one is a lot of times these ones have a base that runs through the middle. It probably is possible. I mean, not even probably. Let's see. How do I want to word this? We may want to, as a design option going into today, try to design it in such a way that this section right here does not matter. Whether or not this is 2020 extrusion, conduit, does not matter. We make a mating mechanism right here connecting the encoder, and then even if you have something pre-built from online, an A-frame, let's say, pre-built from online, even then you could probably go ahead and design a simple connecting piece and then connect these 2 pieces as an option. So that is where we are at with all that. These guys, motors. So one of those things, again, the motor doesn't necessarily matter so long as it gets the job done. Again, it could be your hand, it could be a crank wheel, it could be any number of things. Could heck be a stepper motor. I have, whoops, that was the wrong button. Out of my box of random electronics crap, I have these 2 little motors staying around. This one is out of a craft box, just a introduction to electronics box. And this guy is weak enough to start with my hand. However, it is spinning very quickly. The fact of the matter is that if something is spinning very quickly, you can always gear it down to get more torque, or gear it up. I can never keep those 2 straight. I think it's geared down, but it may be geared up. The fact of the matter is that basically you take this speed and you exchange this speed for torque. So we could, in theory, use this as an option. However, I also tested out this guy. Leads are a little short, but we can always fix that. Can always solder more on. This guy is quite powerful. I tried to stop it with my fingers, and I nearly lost some skin. That may in part be due to the fact that it has a little sprocket on the end here. It's going to be a little difficult getting a perfect match for that sprocket. 3D printing a perfect match for that sprocket, but I think I'm going to try, just because it does seem to have more torque than this guy. Again, seems to, and I'm only saying seems to because I could have just, nearly injured my finger because of the pointy parts on the sprocket. That's a possibility. It may not necessarily be because of the torque, although I'm a little skeptical. I do think it was because of the torque. So, one of those things. I will attempt to use this guy, but again, the mechanism for turning or pulling the steel does not, or I say steel, sorry. I work with steel at work. The mechanism for pulling or pushing the material, whatever that be, whether that be ribbon or wire or string, for all I care, doesn't necessarily matter, just so long as it gets the job done. So that is all that. So let's hop into Fusione. I have not done anything at all in here so far. Did not get us set up for anything because, again, I figured it'd be easy enough. So, actually, you know what? I take it back. Since I knew we were using the encoder, I really should have come in and pulled the encoder in. I should have a model for it. Yeah, I definitely have a model for it. I will be using the larger encoder. When I did the, the project spotlight thingy with Corone's voice box, whatever you want to call that. I forget what terms I used exactly. It's been a little while. Rather, the point being is that I did have this encoder. Where did I put this encoder? Let's see. I had this coder modeled in here, so it should be around here somewhere. I modeled my... was it this guy? No, this is a stepper motor. These are the mini stepper motors. Yeah, I modeled it myself, so it should be around here somewhere. Let's see. And again... stupid me, since I knew I was going to be using this one, there it is. Since I knew I was going to be using this one, I should have made it myself. I should have imported it before we got started. Let's see. Yeah, I guess I want this coiler uncoiler in here. Alright, insert. I will be rotating this, actually not that direction, go back to 0, this direction, maybe this direction. Why? Nah, we will go 90 this way. I take it back. Alright, this is the, let's see, yeah, I guess I'll design it in this orientation, that's fine. So there we go. One thing I will say about this encoder, I found that these measurements I got for this encoder are a little bit wonky. They don't necessarily make sense for these mounting holes. I'm sorry, for these 6 mounting holes. So it's one of these things where, while I'm going to project those, if you in theory take this project for yourself, you don't need more than 3 bolts in this thing to begin with. You can probably even get away with 2. Chances are that's all you're going to be able to match up to the holes to begin with. Because again, for whatever reason, and one of those things, quality control is sometimes not always great. But for whatever reason, the holes to mount this thing are not in a reasonable place. And therefore, they are unlikely to line up with your actual physical project, unfortunately. So just be aware of that going forwards. So, all that out of the way, let us see. Actually, you know what? I think, well, So there are a few things here, and actually this is something I should have mentioned while we're over on the camera, and I just turned the lights off, but give me half a second. Alright, back to camera. Lights, camera, action. I do not have... Actually, you know what? Let me check my box really quick. 1 second. There we go. Alright. You will get this, in my experience, is predominantly the ID that I found on most 3D printer spools. This is a 3-inch ID. This, however, is also seems to be popular in some circles. This is 2-inch, about 50 millimeter ID. The inside of this, however, I don't know if you can see that, but this is actually a lip right here. So this is one of those things where this is a little bit of a hassle to design around because you don't know necessarily what ID you're going to be getting, for one, and for two, with this kind of lip in here, that makes it just kind of difficult and annoying to deal with. So for example, this one does not have the lip, so you can literally just toss some bearings in here up against the edge and you're good. This guy has the lip, and therefore you can only either put the bearings on this side here, or you need to get the bearings in there and then open them up. Now, to solve both these problems, we can actually do that. We can actually put the bearings on the inside and then open them up. The one thing I will say is that there are ridges on the inside of this one, which is a bit annoying. Again, it's going to be nearly impossible for you to see on camera, but take my word for it. For whatever reason, they put ridges on the inside here, which makes that a pain in the butt to move. Now, the absolute easiest thing to do is just put a shaft in there. Okay, you just put a shaft through the ID, and that is how most 3D printers are set up. They just have a shaft that goes through the center of the spool, and then the spool just rides. That is fine for decoiling. That is not fine for coiling, because we need to move the whole entire spool. So that is one problem we are going to run into here as we are designing, unfortunately. So let's see. Let us start out with the encoder part, because again, that's the most important part, and that is also, thankfully, pretty simple. I have done designs like this before, and actually, let us hop up here. Do I have that encoder? There we go. I did this encoder. Nope, that's not the right encoder. That was me designing my own custom encoder for funsies. Is it under miscellaneous? Let us see. I did an encoder demo at one point. And point being is that I would just steal that out of the encoder demo if I knew where I stored the encoder demo, where exactly I decided to put that. I decided to save it at. Did I put it under test pieces? No. Let's see. All right. I'm not seeing anything obvious right here unless I'm blind. Ergo, we're not going to worry about it. The one thing I will say is I believe, if I recall correctly, a diameter of 6 inches, the software math worked out the best, I believe, was the moral of this story. So we're going to go ahead and start with that. So this, we're going to do encoder mount, new component frame, and we'll make actually, you know what, new component encoder wheel. So this encoder wheel, and I'm gonna slide him down here really quick, and we can go ahead and break that link, because why does it have essential dependencies? Huh. I don't think it should, though. I don't think I used anything in this project to begin with. Oh, okay. Gotcha. So it's just because I didn't do it right away. Gotcha. The only other question is, are my joints? Yeah, it looks like my joints are still in place. Cool. Okay, good deal. So we are finally there at the starting line. So we'll do the encoder wheel first, actually, before I do the frame. And I'm just gonna toss. Do I have a face, shaft, construction, plane? Cool, I do. Good deal. So we'll take that plane as our starting point. Project out the shaft. Okay. And then we're gonna just toss the wheel on there. Now the wheel, it's one of these things. I guess for this project, I will go ahead and put a hub on there and a set screw. Oh no, that's right. That's what I did last time. I was gonna say I don't recall doing that last time, but that is because last time, and one of these things. Let me go ahead and hop in here. Again, I'm trying to keep more organized for future, so I'm going to name this really quick. Wheel overview. Last time, what I did was I just took advantage of the fact that this shaft is D shaft and printed a D shaft, and it worked out just fine. So that is, I believe, what I will do again. So we'll just make this 3 millimeters. This will be, yeah, I guess at 3 millimeters. So this is actually going to be TPU on the outside here. And then I will just include the rim. Rim can just be 3 millimeters as well. I'm not expecting all of this to have particular, particular weights, forces put against it. And then 3 inches to the outside of the TPU. The diameter, or no, 6 inches. 6 inches? Maybe it was 3. Maybe 6 inches worked out really well, but I ended up with 3 just because I didn't want to print in a 6-inch circle. Actually, do I have this over here on my shelf still? One sec. I do. Okay, cool. So I've removed some parts from it. We'll come back to the camera. I haven't turned the lights off, so we don't have to do lights camera action at this point. This was the demo I put together. I removed some stuff from it, but basically here is what our encoder will look like. So over here, these bolts is where the encoder will get bolted on. Again, the shaft goes through there. We've got this wheel with the TPU on the outside, and I will go ahead and reuse this TPU because there's no reason to waste it. And frankly, I'll reuse this hub as well because, again, it's just plain generic. But one of those things, idler wheels on top. I had some rubber bands pulling down on these idler wheels to keep it up against the TPU. And one of those things, so long as you have enough friction, so long as the friction for between the wire, ribbon, whatever you're putting through here is high enough for to overcome the encoder wheel friction, which is frankly pretty low, then this will spin instead of slipping. That's just basically how it works. Is if it is easier to pull the wire through with force down on here than it is for the wheels to spin and this, then the wheels and this will spin because those are lower, or I guess I should have said it the other way around. Basically, if these are more free spinning than the wire coming through it or the ribbon or whatever, then you're not going to slip any. There you go. That's all I'm trying to say. And the fact of the matter is that these are very low friction. These idler bearings and this wheel on the encoder are very low friction as compared to the pressure between whatever you're putting through here and the idler wheel / hub. That took a bit longer to explain than I expected. It's a very simple thing. But regardless, this does appear to be a 3-inch wheel, not a 6-inch wheel. Again, I think the 6-inch wheel worked out the best math-wise, but again, printing a 6-inch wheel compared to this 3-inch wheel, it's quite a bit of a difference. So, hop back over to Fusione, and that 3 inches is correct. And then I will go ahead and just model out these spokes, or one of these spokes at any rate, because one of those things we will circular pattern the rest of it. So send this straight up, centered, vertical, and those look like 3mm spokes. We can quinky that to make sure that it is above. Oh no, that's right. It's supposed to be tangent. I take it back. It was not supposed to be quinky dink. It was supposed to be tangent to stay above. We want the spokes to not have a gap on the outside of the hub. So you can see that this gap in here is inside the hub itself. That's how you want it. Otherwise you end up with gaps in your print, which is not bueno. And then down here to the bottom part of the hub. This part, however, is the opposite. This part gets quinky dinked because you can see the gap is now on the inside of the center hub. And that is that. Pretty simple to design. So now we just extrude out some stuff. So we will be extruding all in this direction from our right to our left, because that is where we have shaft. We did at the end of the shaft, so if we went symmetrical like I tend to do, that would not work. And frankly, one of those things, back to just using what I have, I came up with this size for a reason. I could have made it a little bit bigger, possibly. I don't recall actually whether or not a little bit bigger fits on the shaft, but let's see. This is 13mm, it looks like, which is an odd number. That's not 12.5mm, so, or 12.7mm. It's 13mm. I guess that is the size I decided. Oh, okay, there you go. So there is that. You can see that actually goes all the way, according to this, to the to the front part of the face, that hub on the face. It's one of these funny things. It's a little silly for there to be hub on the face like that, but I don't know. I guess it's not that silly. Well, it feels silly to me only because you have the mounting holes already. But regardless, so that's why that is 13mm. I'm actually going to go ahead and back that off a little bit because I don't want it going the full length. And furthermore, actually, I guess I'll put the D shaft in there afterwards, because the D shaft can't go all the way as far as we're going here. So let's back this off to, let's see what 12mm look like. So long as I have a gap in there, I just don't want to be flush up against the face. And it's one of those things, our physical design that I'm using in real life will be the full 13mm, because I can't change that because it's already printed, but I'll live with that. And chances are, if I put this on the encoder, it's going to hang out the front of the encoder a little bit, which is something I'll just have to worry about when I get there. So 11mm looks about right. Let's see. Yeah, I do have this selected right here. That's good. I want to make sure. And this guy up here, we need that selected as well. And that guy right there. We want to make sure we don't miss those. It's actually pretty easy to do when you do it all in one like this. And new component. Yeah, new component. Okay. And I'll call this wheel hub. And now inside of the wheel hub, I'll go ahead and put the spokes in. And I shouldn't actually have to get those other guys. Like this gap down here and the other one really shouldn't be necessary. So just distance to object and join. Attempt to do object. It's having a little bit of an issue. Okay, join, and then our circular pattern, and I've got 6 of them on my current design, so we will go ahead and do 6 of them here. That is a bit arbitrary. It's just what I got. And let's use the center hub. Attempt to use the center hub as our radius, or as our rather axis. Cool. And now we can come back up and extrude out the TPU. Do. Wheel rim. Or, I guess tire. I'll call it a tire. That's fine. And we'll grab some TPU out of the library. Alright, evidently we have a live update that it wants to use before I can do the materials. That's going to bother me, so I'm going to go ahead and hit the save button. And you're going to go to the background for just a second as I restart this. Oh, actually, I'll send you over to camera. And then you can watch me play with this wheel while Fusion restarts. Actually, I gotta hit the button for Fusion to restart because I just closed it. Fusion, there we go. Hey, look, it's a wheel. Entertaining. Am I entertaining? I guess one thing I will say about this is there's not very much reason not to design it very similar to this. Maybe, it's one of those things. Yeah, this is pretty minimal to begin with. The only other thing I'm thinking about is just how this is tensioned right here with the rubber bands. This is a little bit awkward to get these rubber bands on here. So, maybe we change that, but otherwise the height and shape again are pretty minimal. So I don't know if there's any reason to change that. It may be best just to use this as our basis for it. So yeah, I guess that might be what we end up doing. Fusion is back up and running. Open up the Coiler on Coiler, Coiler on Coiler, and swap back to Fusion. Doink. All right. Funny thing is that it didn't say TPU. Oh, no results. Plastic. I thought TPU was a plastic ABS. I could have swore they had TPU in here. Peak, plastic. Huh. They don't. That's funny. I could have swore. Fascinating. Huh. I guess I'll just go with nylon. Okay. Control Z that because that was the whole entire object and I really just wanted the tire. There's the tire, plastic, nylon, tire. Okay. And while we're in here, may as well grab something else. Opaque. There we go. Matte blue. Good deal. So, let us see. Frame now? I guess frame makes sense. Again, I'm just thinking on whether or not I want to change how that A-frame looks on the sample. Just because the triangle shape looks kind of flimsy to me, for one, and number two, back to the, I'm trying to think, the mechanism for holding the idler wheel down is questionable. However, alright, so the alternative, and it's one of these things where, yeah, I guess I can just put a spring in there as the alternative. It's a little questionable, but we can do it. And it's only a little questionable because of the tendency of the spring to want to flop out, but I guess it's not that big of a deal. We can make it work. Alright, cool. Alright, let's go with that. So I'm going to grab the face of the rotator encoder and draw from there. Let's see. That's his body. This is his face. Is that the actual face? It is. All right, cool. So, project out my holes. Again, these holes may not be 100% accurate, but they're what we're going to live with for right now. We're going to need a slot directly above this. Let me turn this stuff off for the time being because I don't actually need any of this other stuff. And that sketch can go off. And we can come in here and name this sketch. Frame. Yeah, I'm just going to call it frame. Maybe frame overview. Just because I used overview for the other one. Okie dokies. And that will be a construction line, but we do want all the other lines there. So let me grab a line straight up here as my reference point, and then we'll grab our slot for the bearings, the idler bearings to sit in, and I've got an M3 in here. That's a radius of 3. I want that to be a diameter, por favor. Diameter 3. All right, cool. And then, so let's see, what do I got in here? So it looks like I went for a, it looks like almost 30 millimeters. So the wheels are actually in the, I guess they're not that much in the way. Yeah, it looks like I went, for whatever reason, a full 35 plus-ish millimeters. Huh. That is a large travel distance. So it's one of these things with our wheel diameter, plus I open this up a little bit more. So let me see what the frame width is actually here. Try to get a good measurement. So it looks to be about 17 and a half-ish maybe. So one of those things, most of the things you're going to pass through here are not going to be tall. They're going to be at best square. And by square, I mean like round, like it could be a circle, and I would call that square because it's equal distance on both the width and the height. So that being the case, in theory, that's 17 millimeters, and we probably want to go below 17 millimeters to begin with. So if we call it 15 millimeters, that is going to be all the height we really need to begin with. So I'm going to swap these guys out really quick. Nope, not those guys. There we go. This guy is what I want to swap out for collinear instead. Okay, I'm not going to worry about it then. So long as it works, it works. So the distance between here and here, I think I'm going to just do back to the 15 millimeters. Should I bother? Now I'm going to leave it at 15 millimeters and just ignore the fact that I have those circles there, which are taking up some space. Yeah. Okay. Oh, I do need the rim though. Project. I do need the rim. The tire. There we go. Because we are going to need to... Oh, that was hilarious. Why did you do that? Huh. Okay. I wonder what... Huh. So this is really an error, huh? I wonder... Yeah, I don't know. All right. Regardless. I'm going to toss in here. This is going to be my 608, or not 608, 623 bearing, which would be a 6 millimeter diameter. Assuming I remember that correctly, because it should be a 3 millimeter ID. 623, yeah, 623, 6OD 3 ID. That should be correct. So in theory, this is the idler that I'm using, and at the lowest point, that is going to be tangent to that. And that's going to be a 0 width item that we're pulling through the encoder. And then we can go up to, again, this is technically a little bit off because, again, this 6 millimeters, 3 of it will be down here. Yeah, I guess, you know what, let me go ahead and add the 3 just to ease my mind, because I do want the full 15. So, I mean, technically speaking, that 3 is down here, right? That's included down here. So I'm actually being a little bit silly, but you know what? Peace of mind is worth it. So. Alright, I turned this to a construction line. I'm going to turn it back. And the reason I'm doing that is because... Actually, no, I take it back. I will turn it back solid. I was going to use it as part of the frame, but I don't think I will. I think I've changed my mind, and we're just going to go tangent with a box. Keep it simple, stupid. For the top side over here, let's see. So again, I'm thinking I'm going to put a spring up in here. Compression spring. At its max height, it's going to, well, at its minimum height, yeah. So at its max height, it's just going to be tangent to this circle right here, down here. But at its minimum height, fully compressed, it's one of those things, if I determined how many coils it's going to have, that would make this easier, the coils and the spacing of the coils. Well, no, actually, only the coils matter, not the spacing of the coils, for what I'm about to do, which is determine the height at which it presses against the roof. If I did the math and figured that out, this would be a bit easier, but it's one of those things, it's always, you can always take a larger spring, have it pre-tensioned at the bottom anyway. I mean, you want it a little pre-tensioned to begin with, but point being, is that there's a ways around it, and you can leave extra space at the top anyway, so I think I'm just going to do 9 millimeters is what I think. Now, the next thing here, before I do that, let me get this set here, because that spring needs to slide as well. It needs to be contained and kept in a line with this, with these idlers right here. I'm just trying to think whether or not we need. So if we hop over to camera really quick. So I've got these spacers in here, okay, on the inside. I'm thinking I'm just gonna build a little cap basically with those spacers as part of it. And the cap on the top side of the cap is where the spring will be housed, okay? And in that case, in that case, this slot basically could be used, is where I'm going with this. So this slot, half of it could be for the bolt, the third bolt to slide on. And at some point, the third bolt won't be able to go any higher, and there will only be slot left for the compressed spring, is what I'm thinking. And the fact of the matter is that I don't know that it necessarily matters to do it. So for example, this could be another bolt right here connected to these guys. So these guys could connect to another bolt right above it, and that bolt could have the plate that the spring is attached to. The only thing I'm thinking about is that spring will want to wobble, although it's one of those things where if I use both of these bolts, so if I use 2 bolts, this one here and that one there, and connect them, then it can't wobble. Yeah, right. One of those things. Funniest part of doing these design streams is that I always complicate things. I always say this is going to be simple, no big deal, and then I complicate them, and it's yeah, it is what it is. I am going to go ahead and do this again. I said 9mm here, so I'm just going to go ahead and live with that consequent for the moment. I'm figuring a 3mm or a 4mm cap on this side and a cap on that side, and then the spring squished in between it when it's at the upmost position. That is probably not enough space though, so let's go 12. Okay. Now the next part is this frame right here. This frame needs to be tall enough to house... Oh no, that's right. No, it doesn't. I take it back because we're not doing the coil on this side. I take it back. Okay. So at this point, we just need some clearance space. So I was going to say some clearance space for the cable, but the let me go ahead and turn the rotary encoder down. So you see how the cable comes out the backhand side here? I was going to say some clearance space for that to come out, but we could have this encoder upside down, right? So the cable could be coming out the top side. So we don't actually need that space. In which case, this 3 inches right here, which should be 3 inches. Let me just double check that I'm not going crazy. It is. Okay. We can just give ourselves a little bit of extra clearance from that guy. Let's say 3mm. So the encoder wheel is 3mm off the ground. The encoder tire, however you want to phrase that. All right. And that is the rough shape of the frame at this point. Again, we can change the shape from here, but that is more or less where we're going with this. And let's see. I made mine a little over 5. I don't know if that's just measurement. Sorry. Actually, let me leave that on. Oh, dear goodness. Let me click this is what I was trying to do. Okay, yeah. So that looks like that was just to this edge here. So the 5mm. It's one of those things we technically don't need to have it right to that edge. The only question is whether we want it right at that edge for any reason. We could just as easily make this 3mm. It's not bearing any real weight, is the fact of the matter. And the only difference here being is we just need to make sure our spacers get from here to the wheel. So yeah, you know what, I'm just going to leave this at 3 then for right now. Let us go ahead and do new component, and we'll make this the left wall. This is the front, right? Yep, that's the front. So left wall. And I am actually, I take it back. Let's go ahead and throw some connection points in here to frame it out. Because I'm not going to print a whole entire box, kind of like how you saw on the camera. I have spacers just keeping it apart. So it makes sense to do that. 3mm. Actually, don't do that. Let's just do 2mm wall thickness. And then I'm going to add just a little bit of clearance to keep it from the edge. And then we'll tangent up. What did you do? Did you get connected somewhere? That would be very unfortunate if you did. Yeah, it looks like you did. There we go. And are you connected? You are. Okay. And we, yeah, I guess we need all 3 of these guys on this guy as well, unfortunately. So we'll get this guy situated and then equal signed that guy, and that guy. And then same deal up here. Don't have any connection points up here, so we're groovy. Tangent. Work our way around, get all the frame out, and then equals. One of these things, a lot of times I do mirrors right. We could mirror left and right. That would save me a little bit of this work. We can't really mirror north and south. We'd have to arbitrarily decide that. Well, there's a couple things. One, we could design this on the center of the encoder mount origin, and then we could mirror. And then we would have to align the encoder mount with everything else. Alternatively, I just put the extra work in and we don't have to worry about hitting the align button, because again, the biggest problem with the align button is that it does not forward propagate, which means that it is not reliable, unfortunately. So I'd much sooner do it like this. Okie dokies. And we can go ahead and mirror, create mirror, left wall. Oh, actually, we'll come back over here and let's see, which one do I want? I guess the hub, because the wheel is based off the hub anyway. So we're going to go ahead and get ourselves a mid-plane here. Okie dokies. And mid-plane. That is X mid-plane, more specifically. And then come back up here, as I was saying, and now mirror this component, that guy, across that guy. And now we can come back into this and get these sheaths in for the M3s that we're going to use to bolt these two together. These standoffs, so to say. Distance to object. There we go. Whoops, that is not the correct object. That object. And new component. And let's go ahead and get some color in here really quick. Red. Whoops, Control Z. Red. Christmas. And matte. Standoffs. Cool. And now we can go ahead and let's see, are my 623s in here? I feel like my 623s are actually in here. 623s. Okay, yeah, I don't have a real nice downloaded asset for this. So, this is what we're living with today. It's something I made myself a very long time ago when I was just starting out and did not download the a GrabCAD for it. That did come in here. Yes, it did. Good. And let us break link. Thank y'all. Modify, align. Get out of my ray radio encoder. That should be right on that point right there, please. Okay. And then the inside face should be with the midplane. There we go. Now that is centered, and we can go ahead and mirror it across to get our 2 idlers. There's no real reason to have more idlers because they're only going to make contact. The fact of the matter is that I technically only need 1. I have 2 because... yeah, technically you only need 1, but I'm putting 2 in here just because. So that's funny. I thought I hit the mirror button, but evidently I did not. Create components is correct. That guy across that guy and hit OK. I guess at this point I will go ahead and yeah, you know what? I should have done this first. Idler assembly. I'm gonna go ahead and slide these guys into the gear. Attempt to slide these guys into here. There we go. And we will go ahead. Actually, I don't have a bolt there, so let's come back here to frame overview. 3 millimeters. Actually, I got it set for 3 millimeters. I actually don't think I want to do that because I already have the 3 millimeters in there, so I'm going to instead tangent that. And now I can go ahead and distance to object here and new component, and this is just going to be a bolt or a rod. It could be either. I'll call it a rod. Idler rod. And now we can come in for the fun stuff, which is, well, first I want to turn these construction lines off. There we go. And by construction lines, I obviously mean construction planes. Okay. Now, as I was saying, we can come in here and start doing the fun stuff, which is designing that spring mount. I'll start it on the inside of the left wall. Easy peasy lemon squeezy. Come in here. How did I not create you as a child of the idler assembly? I do not know. That is a little vexing. Huh. I don't know how that happened. Okay. Regardless, a new component. New component. Brain is working. Yes, brain is functioning. This will be bottom of spring assembly, or maybe I should just do a spring assembly and then bottom of spring assembly. One of these things. Nesting components this far down is maybe a little bit silly, but I'm not too concerned. And now grab that guy and project out all the stuff we need, which is that, and I think that is actually, you know what, I'll grab these edges as well, just in case. We don't really need these edges, I don't believe, but just for the sake of completeness, I believe I will. Okay. Do that. Turn the other stuff off. Boop, boop, boop. And boop. All right, cool. And this sketch is right here. There we go. All right, so here's my bolt. I'm gonna need another bolt, which is going to need to be, well, we're starting it out here. It's one of those things. Technically speaking, it doesn't necessarily matter whether or not this is tangent to this, but that's where we're going to start it out. Because, actually, you know what? We will not make a tangent to that. I'm going to go ahead and put a floor in first. Yeah, that makes sense to me. Actually, no, it doesn't make sense to me. I take it back. What does make sense to me, though, is putting a little bit of... So I said a floor. The floor doesn't make sense. However, a sheath around this does make sense. Just a 2mm. We can drag that up, and then we can give ourselves a little bit offset. And this I'm actually going to do all the way down at 0.5. And then we can tangent this. There we go. And otherwise, this guy down here to connect to this guy, and I can go ahead and make him solid. We'll go ahead and give ourselves another 2mm wall. And then connect these guys up to these guys. This should not be like that. These should be tangent. There we go. Tangent on all four sides. So this is the linkage that pushes down on the idlers, and then the spring is going to go above this. So I'm going to build this out first, and then I'm going to do the spring platform on top of this guy, is how I'm thinking on doing this. This may get a little bit ugly, possibly, and it may be one of those deals where I may want to do a loft. So do an intersect off of this bolt, do a loft from there up to the spring platform. That may be the best way to go about this, but we will burn that bridge when we get there. Yeah, all of this goes. So we will go from, where is my bearing? There we go. And just for the sake of completeness, I'm going to go ahead and make sure that I say specifically from that object to that object. So there's that. Yeah, new body's fine. Just need to make sure I don't go insane. And then we'll go ahead and mirror that body, just the body this time, not the component. That across our midplane, everybody's favorite midplane, which is down here. And then we'll come back to my sketch, and this sketch is spring platform, bottom spring platform. There we go. And as I was saying, go ahead and extrude this the full length. Again, just going to be specific here. Something I've been trying out recently, rather than relying on sketch planes, we're going off of objects instead. And join. Alright, so this is now attached to the idler rod at the bottom, and another rod that we'll put in here. So we'll come up here really quick, extrude that out. Distance from object, and we want to go from the outside of the left wall to the outside of the right wall. And new component. Alright. So now this does not want to twist because it has 2 points, right? And it's 2 points in a slot. You'll also notice that this is what I was talking about earlier. You see how this now is going to stop before there, which is why I was talking about making it taller, and then I said I was being paranoid. Turns out I was not terribly paranoid. Turns out I was more or less correct. So, however, what I was not taking into account is the problem is all this extra meat in here. So this extra sleeve and the extra offset is what killed me for the most part. So I will go ahead and come back down here or up here. I think it's up here, frame overview. And we'll change this to 25. Just make it a full 25, and I'll worry about the consequences later. So now we want to come down to bottom spring assembly. And again, I think maybe the best way to do this, and not the best way, but one of the ways and the way that I feel like doing it, is to do an intersect off of this guy. Let's find the origin plane. There we go. And we are still on top. We're still on top. Good. So do this. Go up 3 millimeters for this for my wall thickness. So these are my 2 planes I'm lofting from. And then I just design this off of that. So we'll go ahead and grab this wall. Actually, rather than the wall, I think I'm going to take the edge. So that edge and that edge. Okay, and then the intersect of this body. Okay. And turn these guys off. Regular rod. The body. This I'm gonna rename really quick to spring. Bottom spring assembly rod. Okay. And then I can turn that off too. And then this is the bottom spring platform bottom loft. That's a bit verbaggio, but we're not going to worry about it. Bottom of spring platform. I'll just call it that. And this is top of bottom spring platform. Cool. And now I can turn this off to get it out of my face. And the 623 is still on. There we go. All right. Cool. I was thinking I was going to need the midpoint of these guys, but as it turns out, I have the midpoint of this guy, so I don't need to worry about it. So there's that. We're going to need, and one of these things, I don't want to accidentally put this on the origin, so I'll put it over there and then concentric it. 3 millimeter wall for safekeeping, and then make this guy extra big, concentric, and a little bit of offset here from the wall. Like 1 is fine, and that's just a construction line to tangent against. And that will give us our size that we're working with. Although this, what I just drew here is the actual, yeah, okay, whoops. So this is what we're lofting up to. Whoops. I guess I will turn this, instead of deleting all this stuff, I will turn this, and then I am going to go ahead and grab these guys. All right, where is that? There we go. All right, cool. So this is the bottom of my loft, is actually what this should be. Yeah, I don't think I'm going to screw anything up here, so we can go ahead and stop there. That's the bottom of my loft. And then off of the top guy of my loft, I just basically need this guy. Oh, derp. Project that. Okay. Is that all I need? It is going to look a little bit funny, but technically speaking, that is all I need. I'm pretty sure. Yeah, I'm pretty sure that's all I need. Okay, so this is bottom. Actually, let me copy this. Paste this. Somehow missed the Control V button. Top loft. Cool. Groovy. Now let us go ahead and loft this up. And again, this is going to look a little bit silly, but I'm willing to take those join. Yeah, you see this edge right here? Kind of saw that coming. Yeah. Let's see. How do I want to solve this problem? I guess. Okay, so this is actually how I could do this. I'm going to hit the join button for right now. Come back to here and toss a tangent line directly across here like this. Because that's where I'm starting the loft from. And then when I do this extrudes rather, not these, this extrudes, we can, okay, and there we go. And that solves it. Okay. Now we don't have the edges because we never drew the edges, and we are groovy. So now I can toss another, or actually I can just reuse this one. Reuse this one and then project out my original lines that I had over here. Let's turn the body off. There's that. And extrude that up. And this is where the spring is captured in. I was talking about a 4mm capture point. So the bottom of the spring will be held in here. And that is that. Again, one of these things where I'm feeling like I've overcomplicated this a little bit, but it doesn't look terrible. And also bodies. I've been forgetting to name bodies as well. Back to when I get to the 3D printing part, that becomes an issue. So this is bottom of spring assembly. The idler, I'm not printing the idler rod. We'll turn it back on though. Actually, no, we won't turn it back on. I take it back because I actually don't want to see it when I do the top of the, how do I want to do this actually? How do I want to do the top part? I think I actually, so there's two options. The two options is, let's back up a little bit, take a step back, and put the standoffs in here. So the two options are to replace these standoffs on the top here with a flat plate, and then from the flat plate do basically the mirror image of this, so just a capture on the flat plate. That is option number one. Option number two is to maybe put a couple more standoffs, a couple more bolt holes rather, and then put a smaller plate that just connects to this in the middle. So one of them uses more bolts, which is more expensive than plastic, although to be fair, plenty cheap enough. The other option is just to print more. I actually think I like the just print more option better, interestingly enough. So I think that's what I'm going to go with. So let's see if we can find the standoffs really quick. There we go. So I'm going to go ahead, and all that work I did hitting the equals button and making all those extra guys is now not going to happen. And we will now do a plate on the top there. So hop back in here and top spring assembly. New component. Top spring assembly. Okie dokies. And we actually do not have a top of wall, I don't believe. Yeah, we do not. So hop back out really quick. 2 seconds. Make that. Actually, I take it back. Because it's easier to design the plate. Is it easier to design the plate? So I don't have to extrude out the holes for the mounting holes if I design the plate from the left forwards, but then I have to extrude out this circle, but I can just reuse this sketch anyway. So Yeah, I think this saves me just a little bit of work doing it this way. So we're going to go from the left, project out, turn off the right wall and the standoffs, and then project out these guys. No, do the whole entire wall. I take it back. Do the whole entire wall. Construction, and then toss a plate in. Plate in. 3 millimeters. Okay. Tangent. Collinears. You guys have seen me do stuff like this 1.5 million times before, so it shouldn't be any big surprise. There we go. And extrude that out. Left wall, right wall. From object. Nope. Incorrect object. Try to grab that object. Try to grab this object. And yeah, this can just be a new body because we already created the top spring assembly. It is a bit thick, I will admit. Thicker than it really needs to be. Well, only thicker than it needs to be in the area that we're not using. Huh. Ha 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 ha. Yeah, you know what? I am going to change that. So let's do this. Make that equal to equal. That equal to that. And then on the extrusion, nope, never mind. I take it back. This is going to look a little silly if we only do that. So let us do this to make it look less silly. And Control Z. Throw a 3 millimeter line in here. Not like that. Make this parallel to that, and then 3 millimeters because we need a little bit of a wall to go against. Yeah, we're saving a little bit of space here. That's fine. Let me look at that again. Yeah, I still need this line in here. Okay. The magical fusion mini line. Cool. And right angle. Finish. And change this extrusion now to not include that part. There we go. We're saving ourselves a little bit of plastic. And now, as previously discussed, actually I can just use that face. I mean, this is a little unconventional, but you know, it'll work. So minus 4 millimeters is what I was using for that, and join. There we go. All right, so that is the entirety of the spring assembly. So this is top spring assembly right here. Spring assembly. Okie dokies. Oh, this is silly. So I have mounting holes on each side. It's not that big of a deal, right, guys? It's not that big of a deal. All right, fine. It's a little bit of a big of a deal. Let's cop in here. Do I need the boundary fill? My brain is not exactly thinking right now, so I'm going to assume no. Project. Turn these guys solid. And solid. And then that did not turn solid, did it? Let me turn the body off. There we go. Do it this way. I was drawing boxes because it was hard to see to select them. So let's just fill these guys in here. Oh, that's funny. I know why I did what I did. I was trying to figure out why they ended up as construction lines. My original intention was to turn everything to a construction line because I wasn't using it. And then, okay, cool. Yeah. Don't have to worry about it. And then after I was done, turn those adjust those 6 into solid lines. That was my intention. So my intention was to go like this, hit the construction line button, and then come back and turn the other ones back to solids. And I didn't do that. I skipped start part 1 and then started turning the other ones, toggling them. So that is where I went silly here. Now this guy right here, I did not fill this guy in. Technically speaking, he can be filled in. Yeah, you know what? Let us go ahead and, yeah, select that too. Now it's just a box. Okie dokies. So, get these body names in here. Left wall. Right wall. Turn the standoffs on. These standoffs, one of those things. Standoff. Standoff. These guys might similarly be replaced by a plate. As you can see, this is just kind of floating in space right here. It's not connected to anything. The reason I'm not right now is because I'm thinking I may just connect this encoder station, this encoder mount, on the outside. So I might have a linkage that goes on the outside and then just gets bolted to these bolts instead, is what I'm thinking. So that is why I haven't turned these into a plate yet. And one of those things, once I get this bolted to anything else, then this will be more stable. Right now, obviously, if you're looking at this, you can tell this kind of wants to topple over. I'm not as worried about it once we get everything else attached to it. Point being. So, that is where we're at for the moment. Actually, let me really quick throw some colors in here. We haven't used yellow yet. There's yellow, and I believe I'm out of default colors now, so let's get some of ours out of the library. Okay. There we go. That worked that time. And light blue. Turn the wheel back on. That and that. Turn the X-plane back off. And is there anything else we need to toggle? Yep. These guys. Should have, there we go, wheel hub and wheel tire. TPU, I'm going to put that note in there just because that's kind of important. The reason I'm using TPU is because in theory it's a little bit, well, it's more flexible, so if you have anything hard, it will grip it, kind of wrap around it, you know? And then the other reason is because I've read, and I haven't tried this yet, but I've read that you can treat TPU with isopropyl alcohol, which will make it sticky, which could help. Again, generally speaking, my experience has been that there is not nearly enough friction in these wheels to need this wheel to be particularly sticky, but that has just been my experience. And the point that I was getting to there is that in that case, so long as these wheels spin freely, you don't actually need them to be particularly sticky. They could, or sticky, or even flexible. They could just be PETG or whatever, but it's better overall for the performance. And it looks like I am somehow clipping down here, which doesn't make any sense at all, because I could have swore on the frame overview, I could have swore I took that into account. Okay, clearly I do not know what the heck I'm looking at. What did I do here? What did I tangent to? Oh, I tangented the bottom of the... Okay, that makes sense. I tangented the bottom of this to the wheel instead of these guys. That makes sense. There we go. Much better. And one of those things, actually, you can see how I have the space here, so this is a little taller than it needs to be. Let's see if we can fix that. Actually, no, I take it back. We're not going to fix it, because that's only because I have these extra clearances in here. So I want to keep those extra clearances. It does look like a lot more than I thought it was going to, but that is okay. That is definitely okay. So at this point, we are done the encoder mount now. And again, one of those things, an hour and a half later, wow, we're back to I started later than I wanted to. I didn't mention this at the beginning of the stream, but neighbor was mowing the lawn, so I did push it back from 3 o'clock to 4 o'clock. Not blaming anybody or anything like that, just saying that is the reason we started later than I wanted to when I said it was going to take me about 3 hours to do the frames, to print the frames for the sliders, and therefore we'd be on stream after that. That is the reason we were not on stream, back on stream at 3 o'clock, which is 3 hours after lunchtime. And therefore we are a bit later than I anticipated. The fact that this is clipping, just for the record, I'm a-okay with. The only other thing I'm looking at is just back to this rod right here, which is not visible. I still don't, well, actually, rather than me saying it doesn't look like enough space to me, how about I just take that measurement? All right. That to that. Distance 16, center to center. But that's 16 minus 3, right? So that's 13, so I probably should be a little bit taller. So let's hop back into frame overview while we're going and getting the idler assembly, spring assembly, and that guy right there. So while we're in here, let's hop back into the sketch and increase that a little bit. I guess by 2 millimeters, 27. I think I said that was just 13 just now, so another 2 gets us our 15 that I was looking for. All right, cool, groovy. All right. So now at this point, what I've been trying to get to for the past 10 minutes is I am going to BRB really quick. So be back in just a second. Hopefully I don't forget to unmute myself. All right, and we are back. Let me turn this off really quick. Officially back now. All right. Do we want to change up the music? I think we will. Change up the music. So with that done, we can now move on to really it's any number of things. So the pulling mechanism again is kind of whatever, and the decoiling mechanism is also kind of whatever. However, I did say that we would design some, so I guess we are. Let us see. So let's do coiling mechanisms. Okie dokies. And I think I will just turn this off and design it in a vacuum. So let us start off with I am just thinking So let me really quick. Let's swap back over to camera really quick. Camera. All right. So let's assume I am designing for this. Now, my biggest issue with designing for this is that kind of needs to get enough friction on here. Now, I did say this, okay? So let's say I make an expanding mechanism to go inside of this guy and the other guy, okay? That way the expanding mechanism can fit both of these sizes, okay? My concern is that this is not a rigid attachment, this expanding mechanism. It's just relying on friction to keep it from spinning, which is okay. And the reason it's especially okay is because if it does start slipping, we won't mismeasure how much we're feeding into the machine. I don't know if I was clear about that earlier. The point of having the encoder is to measure how much is going in and out of the machine. Just in case I did not clarify that one, I just started talking about the encoder, etc., etc., etc. That is specifically so that we can either decide how much we're putting onto the spool or how much we're taking off the spool. That is the reason for the encoder. If this slips, then it's not either pulling or decoiling, coiling or uncoiling any material, in which case the encoder will observe that, and the encoder will not update itself on how much we have uncoiled or coiled, in which case we haven't lost anything, we're just annoyed, is all it really comes down to. So I am going to go ahead and design an expanding mechanism that will fit into both of these guys, and that's what we'll design for this stream. Alternatives, okay? We could drill holes and modify this guy. Either potentially drill a hole through the center here and then through bolt it before we start coiling. Or actually, that's not a good idea. Okay, I take it back. We could do that only on the premise that that bolt is permanent in that case, and then we attach to the bolt mechanically and then turn the bolt. And in that case, it wouldn't matter what our ID is, so long as whatever we're attaching to the bolt is smaller than 2 inches. The other one's 2 inches, 50 millimeters, something like that. So long as the mechanism attaching the bolt. So let me just draw this out just in case I'm not explaining it clearly enough. So if we have an ID right here and we throw a bolt through in there, I'm thinking a fork-like device that is connected like this. So here is a top view, and so that's the side view, right? This is our through bolt. The top view is like this, okay? And then here's our top view of our bolt. So I'm thinking like this, where this thing right here is on a shaft that spins and spins the bolt. So that's one solution, for example, if we want to modify the thing itself. Another solution for modifying is to come off the side here and bolt to the side mechanism like a big pulley that turns this on, using the bolts on the side or what have you. I mean, technically speaking, it could only be one bolt. So for example, here is the OD at this point. So this is the OD. And let's say I have one bolt and then I just have a lever that attaches to a point and just, pistons around basically. So that's another idea. So there are a bunch of different ideas for a mechanically locked system. But again, as far as I can think, one of those things, none of these holes are necessarily consistent across different brands of spools. So one of those things I'm not really going to design for a mechanically locked system. Your third option, okay, I'll just throw a third option out there while I'm sitting here brainstorming, is to have some kind of boot that sits on the edge here, okay? It could be any edge. It could be the top. It could be the side. It doesn't matter. But basically just has drive spinners. So imagine this is our top view, and this is the rim. Okay, this is this part right here. So you're looking at it dead on, exactly like the camera's looking at it right now. This is that rim, and then these guys are spinners that drive that rim. So this is pushing the rim forward. The rim is mounted on something, so it's getting pushed forward and it's spinning. So again, there are 1.5 million ways to skin this cat, and I'm not going to get into it. I'm just going to go with the simple center expansion idea that I had before, and then we'll turn that center expansion idea with either a hand lever, a motor, whatever the heck we want. It's one of those things that's just going to have a hex or D shaft, doesn't necessarily matter, or potentially a set screw, again, doesn't necessarily matter. And anything you can come up with can just attach to that input shaft and turn the spool. So that is what we are going to go with for right now to keep it simple, because again, the point of this stream was to keep it simple, and we have made things a little bit more complicated than I anticipated. So here is my nominal, I guess, I am in the sketch, good. I was going to say, I guess I should make the sketch first, but here is my nominal 2 ID, which is the smallest, or I guess I'll call it 50 millimeters. 50 millimeters is slightly smaller than 2 inches, just for the sake of the absolute smallest we need. And then, let's see. I am currently drawing this from the side. I'm trying to decide whether or not that is a bad idea or a good idea. Or if I want to draw it from another perspective. So actually, let's hop back to the notepad really quick. Sorry to bounce you guys around so much. My idea here is to have a threaded bolt rod. It actually probably needs to be let's see. So there are a couple ways to do this. There are actually a number of ways to do this. So the central idea, regardless of how it actually gets done, is there's going to be 2 points of connection to the rod that we're putting through the center. And then we're going to have 623s in the middle here. And we're going to have a linkage to those 623s that is hinged. And this is a similar idea to what I tried doing with the sanding, my very first design for the sanding. So as we bring these points in, as we bring these points closer together, this is going to go up. As we bring these guys out, this is going to go down. So that will be our expanding, collapsing idea. So one of those things, watch my hands, you know. So this is completely flat. This is, if you look at my knuckles, let's say my knuckles are the hub. As my knuckles come closer together, you can see that my fingertips go upwards. Ignore my thumbs. Thumbs are not real. And then as it comes out. So this is the idea right here. Again, this needs to be hinged at this point. I don't know how difficult that's going to end up being, but we will persevere. So, again, the question does, however, arise. Whether or not from the side is the best view to come from. Let's see. So the argument I'm having against myself right now, the reason why I'm thinking about changing to the front is, let me go ahead and start another sketch to show you. These hinges, again, are going to be a little bit of a problem to print, but if I design them like this, where this is a 3mm, and just as a clarification for anybody that is not familiar, I try to keep the same exact bolt size throughout my designs when possible. So that is why I keep on going to 3mm bolts, because frankly I don't like 2.5s, and 3mm are, you know, more reliable than 2.5s on the frame. That is also why the frame is not using 4mm. Let's say the frame could be using 4mm bolts, but I don't want to have 4mm bolts there and then have to use 4mm bolts. Wow. Okay. On this mechanism. There we go. That is the explanation. I missed. 2, 2. So if I design it from this side, I can design the hinges like this. Tangent, extrude these out, and then come back over and do the wheels and whatnot, the bearings. And that would make my life easier. So this is the linkage that goes on the side for my quote-unquote hinge. And this does seem reasonable. So let me project out. Actually, it's fine to have... No. Let us see. I don't actually want to project that out because I think I'm about to delete it. Change this sketch to linkage. Oh, shoot me. All right, finish. Come back. Come back. I wonder why I can't just hit delete after timestamp. I should create a new mechanism before I do this. Try to keep myself organized in the timeline. So this is a filament spool holder. Expanding filament spool holder. There we go. That is what we're designing right now. Now, I'm back to these linkages. There's that. The through bolt is in theory at the center of the linkage, and then at the tallest point we're going to need I am thinking this correctly, right? Yeah, I am thinking this correctly. Okay, cool. Point is that at the center of the linkage we need at least the 2 inches at the center. So that is the deal here, and that is when the linkages are pretty much touching each other is what it comes down to. It's going to be a little awkward to design, but I think we'll be all right. There's that. All this stuff that I had drawn before and then had to come back and redo, unfortunately. Alright, so we're going to use the origin. This is going to be 50 millimeters. That's our center line. And then let's drag you back a little bit. I've got my nominal 623 right here, so this is 6 right there. And thickness, I believe, is also 3 on a 623. Let me grab one out of the box so I don't have to take this thing apart. And by box, I mean tube. They come in these neat little tubes if you haven't seen them before. Here's the camera really quick while I'm measuring. Try to get over to the correct screen. Bearing tube. And like I said, I think this is 3 millimeters. Okay, it's 4 millimeters. I was incorrect. Drats. So 4 millimeters. 4 millimeters, and then this bearing should be, the top of this bearing should be dead center there. So there is that. This linkage obviously needs to connect to this bearing. Let's see, I guess I throw a little bit of a, an offset here, and then at that point, I believe I should be safe to just make that tangent to that. And one of these things where the distance, where'd the other guy go? Don't do that. You actually should be directly in line with this guy. You should never actually move from this guy, so you should be like that. And do this, attempt to do this. Let me tangent this here temporarily. There we go. I just needed him to get onto the other side, because one of these things, this guy is not going to be able to be directly below this guy. I don't believe, question mark. I think he should be at a little bit of angle. So, alright, I take it back. I think he technically can be directly below the guy. Do I want him to be, though? The problem with him being directly below the guy is that he's no longer exerting effort inwards. He's only pushing up. Is that big of a deal? I don't know. I am a little concerned, so I am going to... Let's see, which angle? I guess I'll call it this one, 80. Okay, did I untangent the wrong thing? It looks like I untangented the wrong thing. Delete that. This is the tangent I wanted to keep. There we go. And then again, the position of this guy horizontally should still be up for debate. Oh no, I deleted the wrong one. Wow, these tangents are hard to find. Okay. Which tangent are you? You're that tangent. Okay. You are that tangent. Now, okay, good. Whoops. Nope. Nope, nope, nope. Don't do that. Can you please go lower? There you go. Good boy. There we go. I want you tangent on top. So, at this point, this is where I'm at, and then the only question is how much space do I want to connect this bearing to it? So the bearing is going to have a through shaft, right? Let me use the square instead and turn construction line off. Actually, don't turn construction line off. I should have left that on. This is going to be 3 millimeters, obviously. And this is going to be connected to a piece like this, I'm thinking. So I'm thinking of building a little horseshoe here. This is what I'm thinking here. Obviously, a little bit of space for it to spin. So that horseshoe. The one problem, obviously, here is that this is like half a millimeter. Unfortunately, I might need to. Yeah, that wall is really thin. Let's see. So it's 1.5 is my maximum, right? So this should be 0.5 right here. That says 0.1. That's that's interesting. Because this is, oh, I didn't actually center up the that is why. Okay. That is fine. Where's the center here? We can fix that. There we go. So there is my 0.5 that I was looking for. Okay. So, anyway, point being, this horseshoe is what I'm looking to build for this guy. And then this hinge would attach to the horseshoe. At which point, actually, this tangent, I have this tangented on the top. Right, do I have this tangented on the top? Yeah, I do. The tangent is somewhere, one of these ones. That guy. So this guy actually would want to be something like, let's see. Let me do this. Or actually, this 2 millimeter offset is exactly what I would want. So the question is whether or not I want to leave this below this bolt right here. So if I keep that below this bolt, that makes my life easier getting this bolt in and out. I actually should give myself the full extra 1 inch right here, or extra 1 millimeter right there. So this gives me more room to get this bolt in and out. The trade-off is that this needs to be tangent, or this ideally would be tangent right here. It is at this point that I'm thinking that I may actually keep this horseshoe that I just really quick slapped together. The connection points are all coincidences, which, as I've said before, I really don't like because they're hard to fix. But this is actually something that I probably will be extruding alongside the hinge, so it actually makes sense to have this in the same design, or have it done before, honestly. So there's that. Now our problem here with this, this is a 2mm shoe right here and wrapping around, but I've got this 3mm bolt with the 2mm thing, so you can see how it looks quite wonky. One of these deals where part of me wants to just offset this completely. So where's my tangent? Turn this tangent off. I hope that was the right tangent. Hold on, Control Z. Which tangent are you? Okay, you're that tangent. So I am good to tangent that one. Now what are you? You. Okay, that's that tangent there, and that tangent there. Okay, gotcha. All right, now, I'm tempted to just do this, collinear this, and have this sticking out the bottom like this. Again, this is a bit ugly. I don't particularly like how it looks, and I'm not gonna. It may print fine. Actually, I take it back. It may print relatively fine. Yeah, you know what? It could print relatively fine. It's possible. And the fact of the matter is that these guys maybe can be 2mm, and then I can open this up to 3mm. Delete. You were supposed to go over here. There we go. So that this is not as severe, and it's a bit more chunky. And then the only question is, how close do we get? I guess I may as well just tangent this line and just use that as how close I get. That does fully constrain our sketch. So the final question is, how many of these hinges do I got? Because let me go ahead and extrude this guy. We'll symmetric extrude for this first one. And the roller diameter is 6, but the so I'm a little concerned about hitting. So 2 plus 2, so my wall thickness of 2, okay, on each side of the bolt is 4, plus the 3mm brings me to 7, but my wheel diameter is 6, right? So if my wheel diameter is 6, okay, there is another interesting way, actually, that I'm thinking about this, to go about solving that problem. If it becomes a problem, we'll talk about it. I think I'm going to go 6 here for the time being, and my walls will be a little thin, is all that's going to happen here. So the point of all this, and actually I wanted to make that a new component. Symmetric overall, 6, new component. Wheel holder. Okay. The point of doing all this is that this feature right here can be extruded. Distance, two-sided, two object here. Distance, two-sided, two object here, like this. This can be extruded like this, and then these hinges, I can put one hinge on the outside, one hinge on the inside. Alternatively, I can symmetric 3 overall, do something like this. This is harder to print, is my biggest problem, but the one hinge just goes in the middle. The 1 3mm hinge gets extruded in the middle and just sits in there. So those are my two options. This is harder to print because I've got to fill this all. In theory, the only way that's reasonable for this to print right now is on its side like this. So this is the bed down here, the printer bed. So since this is the printer bed down here, this empty space in the middle here needs to be filled with filler material with supports. That is my only issue at the moment, is that this is the easier way to do it and requires less printing of these guys. However, it is more difficult to print. The other thing is, well, in theory, alright, so in theory these guys, these hinges shouldn't be twisting along this axis right here. If they were twisting along this axis that I've highlighted, then I'd have to worry about layer separation, because if it's printing on its side like this, this is the way the layers are going, so that is in line with the layers, but it really shouldn't be doing that. So I probably don't have to worry about layer separation with these tabs breaking off. All that said, I think this is how I'm going to go ahead and do it. What is the blue here? Wheel holder. Oh, come on, I hit join, didn't I? I guess I did not hit join. Okay. We did not hit join. That is the way I believe I'm going to do it. So let's come down here. This is wheel holder and hinge. A bit more than I'd like to do in a sketch. I'd like to do the sketch designs a bit more separately. However, it's one of those things. I was working through the problem as I approached it, and that's just how life is. One other thing that I've been meaning to mention for a while now is that you may have noticed that I have not put any offsets in the design yet. And that is because, where are you? Okay, and that is because I plan on doing it all at the end. This is similar to how I did the paper towel roll. And I may not do all the major components all at the same time, but I probably am going to do, for example, all the encoder mount stuff as one offset. And all the, maybe all the wheel holder as one offset. Just group them all. That way it's easier if I need to go back and change offsets to do. Let's see. Wrong button. Wrong button again. I can click. There we go. This is the X mid plane. We're going to mirror that feature across. And I guess I already have that selected. Fine. And now we want to, I'll go ahead and continue to use that plane, actually, since I already have it, to throw the bolt in. So let's project that. Boom, boom. Let's see, there it is. There's that, and I actually want that face instead, so I'm gonna Control ZZ do that, and then project out that face. That's the face I want to be centered on for the wheel. I think... No, I don't think. Let me go back to the sketch really quick to figure out where the heck I put that. Okay, no, that is centered on this face right here. Okay, good. Good? Question mark? No, not good. Not good. That's 2 right there. Okay, okay. Control Z. Project. We're going to go ahead and project out that sketch onto another plane. Where is it? There we go. So I'm just going to grab that center line then. Oh, crap. That is why. Okay, I was going to say, why is it giving me such problems? Because I'm not actually in the sketch. Project. Much better. Alright, there we go. That's my center line that I need to be drawing the circle from. 3 millimeters. Captured nuts. So, captured nut, let's see what it looks like. I may not be able to fit it into this design. It may just have to sit separately, and I might have to just throw a locked nut on it in that case. 5.45. Yeah, okay, you see how it sits over top this? So that is not really going to work out. Furthermore, to the point, 6 millimeters, that actually is a serious problem. Yeah. The funny thing is that I do not recall running into this problem to begin with. So obviously this is not my first rodeo with these guys. I have done... .623. The 6, shoot, the 6 is an oh my goodness, I'm an idiot. 623s are 10 millimeters wide. Derp. I was trying to figure out, this confused me right now what's on screen, because I've done this before and I knew for a fact that the hex does fit within the size of the OD of the bearing. The 6 is for, I believe, single row bearings. It's an indicator on the bearing type, not the OD. I'm an idiot. That's embarrassing. Okay. The 3 is definitely the ID. The 3 is definitely the ID in the 623. The 2 I believe is light duty. I want to say 2 is light duty. Yeah. So, my sketch is a bit wrong at this point. Fortunately, you will recall that on the encoder mechanism, we actually brought the bearing in instead of just drawing the back bearing from whole cloth. So we don't have to go back and fix that. We do, however, need to go back and fix this. This is 10 millimeters. There we go. And at this point, we now have room to go up here. However, I don't think we will. I'll just go ahead and get this collinear so that we're constrained. But this connection point for the hinge could go above. I think I've decided that I like it pushing up on the floor like this in this direction. So I'm going to go ahead and leave it at floor level. However, this does remove a lot of my fears. So one fear that I had, that I was concerned about, is that, let me go ahead and draw this sketch in so that we can see. This is now 10 millimeters. My concern was that this corner right here would be past my 6 millimeter point, which is something I was going to come back and address in a minute. And I was thinking I was just going to go ahead and fillet that down. But obviously, as you can see, I'll still probably fillet it just for the looks of it. But it is not going to interfere with the roller itself. That is therefore everything. The only thing, well, everything to get us caught up. The only other thing that we could do is I only gave ourselves 7 millimeters. Or no, I gave ourselves 6. Yeah, I gave ourselves 6 because I was concerned about that. So back to 3 millimeter hinge plus 3 millimeters on each side would be 9 millimeters. So we can open this up. And the 3 millimeters on the inside. So now we have 3 millimeter walls right here. Length 3, you can see. So that is good, and everything is looking a lot better now. Although, you will see, back to what I was just talking about, that corner sticking out past the bearing is something I don't particularly like, but like I said, I am just going to fillet that down. So, this is like that. We don't really need that. This now, this hex, still does not fit in there. Let's see. I could raise the wall. I don't think I'm going to bother. I think I'm just going to throw that hex nut on there, the lock nut, the Teflon nut, lock nut on there, and be content with my life. So we can go ahead and delete that then. And we'll just extrude out, not that, but rather this hole in the middle. Two-sided. All I could have done symmetrical. A little bit silly not to do symmetrical. Alright, so there is the bolt that holds our, well, I mean, technically speaking, it's not there yet. So let me go ahead and create that guy just for propriety's sake. Distance, two-sided, two object. I think it's this one first. Yeah, it's a positive number. That guy, and that is a new body, and this is bearing bolt. And let us go ahead and bring in another 623. Insert. Okay. Control Z, because that should have been in wheel holder, not bearing bolt. Insert. Okay, turn you off, break this. Which origin is this that I'm looking at? Find in browser. Why are you visible right now? You say you're not visible. There we go. Alright, cool. Alright, modify, align the center of that with the center of that guy. Capture position, turn this sketch off. This is bearing bolt and hole. And then we can go ahead and throw some joints in here. We did not throw joints in previously. The reason I'm doing this right now is just in case this needs to move. So that and that. And this is going to be a revolve around. Let me try to get that. There we go. Okay. And then modify rigid joint as built. That rigid. Okay. Turn that sketch back off. Actually no, we so this is a wheel holder. How do I want to let's see. No, this should work. Question mark. Question mark, question mark. This should work. This is not going to work, is it? It might work. It will work. It will work. It will work. Question mark. All right. Okay. This is... I'm thinking about how I'm going to pattern this around with the hinges. It is a little bit more complicated than I just realized, I think. I may be wrong about that, but I think it is a little bit more complicated than I realized. I think I might pattern this around first and then go from there. Okay, actually, do I need more than 2? Because if I need less than 2, or if I need 2 or less, if I don't need 3, then this becomes easy. Where is the full origin? That is the full origin? That... Yeah, 2 inches is really small. Okay. Okay. Oh, actually. The way I drew this hinge is not correct. This hinge is going 1 inch for this guy, but he needs to be able to go 6 inches. Or 3, inch and a half. So I need to change this to 3 inches. And we need to model for the 3 inches and just assume that the 2 inches is going to work. And this is our example of the bearing not functioning the way it's supposed to. Or the align feature, rather, is what I should say. Not functioning the way it's supposed to. And the align feature always ends up all the way up top. For whatever reason. Not you, actually. You. And you. Okay. Finish. Come back down here. Let us get this patterned. Components. Wheel holder. And you going around there. So let me do 3 really quick, just so that you can see what my biggest concern is. I'm about to do the through bar, which will also have the hinges attached to it. The hinges are coming at a right angle right now through here. I was just a little concerned that this might not meet up terribly well, but I think that probably was just me being paranoid. Yeah, this is probably just me being paranoid. Okay, I am less concerned now. So let us go ahead and draw some hinges then. We'll do that before here. And then the only question is technically speaking, this wheel holder, I think, should be down 1 more level. So I should make a component called spoke. And then the wheel holder, yeah, it's not going to be able to go in there because, unfortunately. So let me come here, go back, come here, go back. I feel like I just got lost. Okay, no, that is correct. Where's my sketch at? Why is my sketch no longer on the... There's my sketch. Okay, whatever. Whatever. Alright, new component. Spoke. And now, if I come back up here, will I be able to move it down? Back 1 though. No, I will not be able to. Okay. Let's see. I want the hinges to be the same component is my big issue. How do I fix this? Can I move it back here? Nope. Huh. Okay. This is what we're gonna do. We're gonna come here, delete all this. Can I please just delete after time? I don't know why they... It seems like they got rid of that feature, as best I can tell. I don't know why. I'm gonna delete that. Change this to spoke. Move this to new component. Okie dokies. And now we're gonna reassign these as built joints. That and that is rigid. Try that again. Whoops. Okay. Bearing bolt. Wheel hump. There we go. As built. 623 and bearing bolt. Revolve. Round the center of that guy. I'm assuming that worked. Okay. One of those things. Hard to tell with that skin. Okay. Come back up here. Now do the hinge. Symmetric. 3mm. Overall. New component. Hinge. And just mirror it across, right? Just mirror it across. Mirror. Components. Hinge. That guy. That guy. And then modify as built. Boink and boink. Revolve around the center here. Do 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 do. All right, here we go. Here we go. Create pattern, circular pattern, spoke around that guy. Let me think. Let me think. All right. Not this guy. Not this guy. Let's come back in here. Okay, I'm being a little bit of derp face. Yep, that's exactly what it is. A derp face McGee. Spoke. Wrong axis. This axis. Nope, not that axis. There we go. All right. Oh, I'm gonna cry. Yeah. The reason this is not lining, so this is the correct axis at this point, which makes sense because this is the axis going directly through the wheel. If you draw the wheel right here, the ID, this is the correct axis. I was just being a dirt face. The problem, the reason why these curves are not lining up is because I have this centered on the center of that axis, and I need to have a bolt going through the center of that axis and the hinge connection point. So we will not be doing that just yet. And furthermore, we're going to probably have to come back. So I don't technically need to change this guy. I could leave this guy at this height because that's fine. I can just move him up, and then at that point, this will be just out a little bit further. This hinge will be out a little bit further. So I technically don't need to move him. I can leave him that length, and then it's just a little bit of dead space. It's just a little bit of extra plastic. Unless I want to move him, is the only question. So do this and then give myself a little bit of clearance there, and then tangent that. And from there, then I can go ahead and draw the hinges for the center of the filament spool. What is green? Okay, that's a hinge. Okie dokies. New component. Central clamp. So this is one of those things where this gets a little bit difficult just because the size. So back to it, it should be a 5 or 8 millimeter. I'm saying 5 because I have 5 millimeter rods. Otherwise, 8 millimeters is what I say as the generic. And at that point, I'm now going to need to. I guess I don't need to. Okay, I take it back. Ha 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 ha. Yeah, the only trick is the method by which we clamp this together is the only trick that I'm trying to figure out right now. I'm going to call this 8 millimeters for right now. 8 millimeters obviously is too tall for these guys. These guys are going to have to be shorter. And then the other question is at 8 millimeters, 8 millimeters, 4 millimeters, 4 millimeters, plus 10 millimeters is 14 millimeters, which is still less than 25. So we should be good getting through a 25 millimeter, fitting this through rather, the 2-inch 50 millimeter hole. Actually, that's 15 plus 3 millimeters for the bottom here, plus this guy. So we're actually getting pretty close, but I believe we still fit if we have it cranked all the way out. So. That does mean that this guy needs to come up more. It's simple. I swear it's simple. We're only complicating things for ourselves. So this is 8 millimeters right here. Technically speaking, this is side on, but it doesn't necessarily matter. So there's that. And this is now going to need to be tangent to that. Okay, fine. Don't be tangent to that. You. Which one are you? This guy? Yeah, that guy. Cool. That goes there. That goes there. And that. Whoops. That goes there. Alright. There we go. Okie dokies. Well, we're saving a lot of plastic, I can tell you that. So. That is. Okay, that is inside that object. Good, good, good. Distance. These guys are. So it technically only really needs to be half plus a little bit. And it even then it doesn't technically matter for us on this CAD how long it is. But I will go ahead and make it about 70 millimeters. So I'm getting 60 on the out-to-out on this spool. So I'm giving it a little bit extra just because distance, symmetric, or no. distance. What the heck am I doing? Yeah, symmetric. I don't know what I'm doing. That's exactly what I'm doing. There we go. And this is a new component. This is center rod. You will notice that I have not named the rest of my bodies. That is because I'm getting hungry. Rod. And this scream, I was not expecting to go this long. So, suffice it to say, after we're done this clamping mechanism right here, and the expanding filament spool holder, we will come back for another part, another unanticipated, I swear it was unanticipated, part 2. Just like always. Let's project that out. Okay. So, shoot me, because we need 2 millimeters here. I did not give myself 2 millimeters here, so we got to come back and fix that. That is back in wheel holder. So this should really be more like 2. I'm going to call it 2.5 instead of 3. Okay, because I don't want to shrink that up anymore. And that will give us a room for the floor over here. 2 millimeter floor, and then 0.5 millimeter between the bottom of this guy and that. You can see that's about 0.5 millimeter. In theory, you can see that. Let me turn this origin back off. Attempt to turn this origin back off. Find the browser. There we go. Okay, so look at project this. You know what? Let me take the intersect of this body. Oh, I guess that makes sense. I'm not intersecting that body. Yep, that makes sense. All right, there we go. That face is fine. I just need something to tell me what is left and what is right. And then we can go ahead and toss some lines up here. I'm going to delete that and make that parallel to that guy. Toss another line up. Attempt to toss another line up. Let me get a slightly less isotropic here. And actually, you know what? That should just be collinear. So there's that. I'm going to find the center of this guy. And that is a 3 millimeter bolt, in theory. Let's turn the spoke off for a second so we can see what we're looking at. So that's where the bolt hole comes through, and then we just need our extra material around it. And this guy, just 2 millimeter wall is fine, and then connect up to that guy. Whoops. Actually, I'm probably drawing this a little silly. Again, a little bit unanticipated. Yeah, you know what? We are going to bail on that stuff, draw the sheath in here, and then come from the other edge. Actually, I take it back. We are going to bail completely. Forward, pretend this never happened. And then we will go off the face of this guy. So, grab a hinge. Grab a face of the hinge. Redo. There we go. Front of hinge. Okie dokies. Come down here to central clamp. And now use that guy. And this is significantly easier to draw. Good bunch of men. I hate lasso. I hate lasso. Why does this even exist? 2 millimeters. There we go. Project this guy out. Or intersect this guy, actually. Intersect. Drop a line. Magical 2 lines of fusion. Excellent, excellent. Why does it look like my line is underneath the edge of the pipe? That doesn't make any my... Oh, that's right. That does make sense. Okay. We're going to have to project because we're off center from the center line of the pipe. I guess I didn't need that face. I guess I could have done center line. But, you know, things and reasons. Don't think too hard about it. Do 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 do. Right angle, and tangent. And I know this looks like we have way more space down here than we actually do. This will be the funny thing is that why you look not right angle? Just a figment of my imagination? I guess just a figment of my imagination because that's going the opposite direction. Okay. Point being, okay. Okay. Okay, you remember when I tried to intersect? Intersect was the more correct thing, and even then it wasn't going to work the way I needed it to. Because we're not really designing from the correct place here. This is one of those things, clearly I'm getting a bit tired. I have a bad feeling that I'm going to run into some other problem before we're done here. So I am thinking that it is probably best if I just go get dinner and then we come back and finish this later. Because I am not anticipating all the problems at this point. So, thank you guys for hanging out with me if you have been. Obviously, this was supposed to be super simple and I made it not super simple, and that's okay. We're still making something cool. Apologies, we did not get through this all in one sitting, but we did start late. If I had an extra hour, then we probably would have, because it would only be 5:30 at this point. But we did start late, so it is what it is. No big deal. Otherwise, yep, we will be back to fix this, finish this design off. One of those things, we have this will be its own little thing, and then to go with this, we can go ahead and design a couple of mounts for it, and then a couple of mating mechanisms for the motor. Those are other things we can design that I did not talk about. So we can have another full stream of design. That is fine. I was hoping to get it done in one and then just do the electronics and run over the electronics in the next stream, but that is not the world we live in right now. So new plan is 2 design streams and then the electronic stream, and then this project will be completed. So one of those things, most of my projects are 3 to 4 episodes anyway. Granted, a lot of the projects are 3 to 4 1-hour episodes, but that is beside the point. We are currently at 2.5 hours. So look forward to the next part of this, and if you have not watched the project update, I have all the other information for other projects at the end of the project update. Plus, it's one of those things, always good to watch the project update videos for any changes that I've made to previous projects. So, with all that out of the way, I hope you have a great and wonderful day, afternoon, or evening, wherever you're at in the world, and I will catch you next time.